All right, let's take care of part 2 here. So, just to be very thorough with vertex form, what happens when you have a number less than 1 that's being thrown in front of the x squared? Really no difference is happening. Again, I'm going to try to isolate these first two away from the constant, just to remind myself that these are going to try to help create a perfect square trinomial, and I'm factoring out a 1/4. So it's like I'm dividing out the 1/4. So 1/4 divided by 1/4 is 1. I mean, that's what I'm trying to create. There's a 1/4 now on the outside, x squared here. When I take x divided by 1/4, it's sort of like saying, what's 1x divided by 1/4? And it's sort of like, how many quarters are in a whole? How many literal, quarters are in a dollar? 4, right? So 1 divided by 1/4 is 4. Your calculator would say the same thing if you took 1 divided by 1/4. So the question now is, remember, the -3 is unchanged. What's the perfect number that we can add inside there to complete the square? Cut 4 1/2, 2. 2 squared is 4. So I'm adding 4 on the inside of the parentheses, which is just code for saying you're adding 1/4 of 4, because there's a 4th on the outside. So really you added 1. That's what you created. You created a +1. So we're going to offset that with a creation of a -1. So now you've got 1/4 times x, cut it in half, squared. Remember, that's a shortcut for factoring a perfect square trinomial. And then, and then -4. So this is the vertex form of the parabola. We've got a vertex at -2, -4. This 1/4 is gonna flatten it. It's gonna compress it. It's gonna make it shrink. It's gonna make it a wider parabola. The points end up being -1, -3/4, which means -4. Ooh, -3, -1, 2, 3, -3 3/4. If you plug in 0, you get -3. Which means you've got a partner point over here. And let's see here. This is also going to be a point. So this is a compression or a shrink. Left 2, down 4. All right. That's all I got to say about parabolas. Now let's talk about absolute value functions, which have a very similar makeup to them. So parabola vertex form, y equals a times x minus h squared plus k. Absolute value vertex form, y equals a times the absolute value of x minus h plus k. Pretty similar, right? So we're trying to make all of our absolute value functions look like that. Fortunately for us on the very first one, it already does. So right here, our a is the third. Our vertex is -4, 2. So you'd go left 4, up 2. That's going to be the start of it. And then there's an interesting way in which we can go about plotting the rest of these points. the 1/3 out front almost acts like it's the slope of a line. Absolute value functions are kind of similar, but also very different from parabolas. It would be like if parabolas were perfectly linear. If they were perfectly linear, you'd get an absolute value function. So it's like this is a line that basically shoots like a ray that way and a ray this way. And it has symmetry about x equals -4. So notice there's a 1/3 in front of the x. This is like having a linear equation in which the m is 1/3. You can plot points by just going up 1, right 3. Up 1, right 3. Up 1, right 3. Or up 1, left 3, because you need to have the partner on the other side of that. So that's what your absolute value function looks like. It's been compressed by this 1/3 here, shifted left 4, up 2. I mean, I could also just plot some points. I mean, I'm pretty sure if I plugged in 0 here, you could do 0 plus 4, 4. Absolute value 4, 4 still. 4/3 plus 2 is 3 1/3. Go 0, up 1, 2, 3 1/3 units. You can still plot a bunch of points by just plugging stuff in. But you can use the slope of that line. One more. Oh, we got an issue here. Did I change the top of this? I did. I need to make an adjustment when I attach that document. All right, so I want to rewrite this in vertex form, which is a times x minus h plus k. So I'm gonna rearrange this inside here, call it -3x plus 7. Inside the absolute value bars, the -7 stays on the outside. Now I can factor out of the expression a -3. But it's still stuck inside the absolute value bars. So this is going to be x minus 7/3. But here's the deal. When you multiply two absolute value terms, you can then separate them into two absolute value quantities multiplied together. So I can take the absolute value of -3 times the absolute value of x minus 7/3. That works. So then I can just take the absolute value of -3, which is +3. So it's like if you're negative inside the bars, you're going to come out clean on the outside. You're going to be positive. And what that does is it establishes a 7/3, which is 2 1/3, -7 vertex. Okay? You're going to go right 2 1/3, down to -7. And you know, at this point, I can do one of two things. I can say, this is a linear type situation, a ray moving this way and a ray moving that way, in which they have slopes of both 3 when they're shooting in this direction and -3 when shooting in this direction. So up 1, 2, 3 over a whole, so I'm at another third. Up 1, 2, 3 over another. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. So then I got partner points on the opposite side. 1, 2, 3, left 1. 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 So it's stretched. It's shifted right and down. And that's the basics of vertex form. Hey guys, I fully expect you to have questions over all of this stuff coming in the next day. So don't be shy with those questions. I'll try to answer them in different ways than I even showed on the video. Okay? Thank you for watching.